Okay, now let's move on how to design artificial neural network. In this section, I will introduce some network types and then I will guide you some general principle on how to choose the number of layers, the number of neurons in each layer, how to choose activation function, and other related problems. When we design an artificial neural network, we have to decide its architectures, basically how it's built. Just like designing a building, we choose how many floors, how many rooms, and how they get connected. In ANN terms, this means deciding on the types of network, the number of layers, the number of neurons in each layer, and other design choices like activation function, some appropriate hyperparameters like learning rates, loss functions, etc. So before designing, you must understand the problem you are dealing with well. Consider whether the problems you are dealing is should be a classification, regressions, or another type of learning. So this will influence the choice of the network architectures, the loss function, the output layer, etc. Then you design the network type. We have so many network types to choose from. And it's recommended to use feed-forward neural network for basic tasks like regression and classification on structured data. I mean the data in the tabular forms. You are recommended to use CNNs and its variants for image-related tasks like object detection, right? Face recognition. Yeah, should use INN or recurrent neural network for dealing with sequential data like time series or natural language processing tasks. The architectures based on transformer, yeah, strongly recommended for tasks involving sequential or structured data with long-range dependencies. So when you already decide the type of network, now let's design the architecture, right? Architecture. So how many layers are there and how many neurons in each layer should we design? Yeah. And as I mentioned in the very first introduction to ANN, yeah, we know that yeah, every ANN should or must have input layer. Yeah, and the input layer will capture the features of the input data. It should matches. It should match the shape of the input data. And I already recommended, right? You should have one neuron to capture one features, right, in the input data. And for the image processing task, yeah, you should design one neuron for capturing each pixel, yeah, one pixel, right, of the image. And the second thing, upper layer is also mandatory layer, right? And in the upper layer, yeah, if you are dealing with the classification task, right, it's recommended to use the softmax activation for multi-classification problem. But if the problem is binary, yeah, it's recommended to use sigmoid. Yeah. And for regressions, linear activation to output a continuous value. There's some common activation function you can use for hidden layer. It's ReLU, rectify linear units, right? And remember, softmax and sigmoid just used for output layer, right? And basing on the task you are dealing with. And for the output layer, yeah, also remember you should design, right, one neuron for capturing each output or outcome, okay, of the task. Uh, to design, right? Next, yeah, you should number. Next is the hidden layer. So how many hidden layers should we have? Yeah, should we have? And to design hidden layers, okay, let follow the principle of start simple, scale gradually. Okay, so you can begin with some shallow network with fewer layers, yeah, and smaller number of neurons. Mhm. And gradually scale up if necessary. Okay, it might reach to deep network with more than 3 hidden layers, and in each layer it might have a large number of neurons for dealing with complex tasks. Okay, and deep network is recommended for dealing with image and text processing. By following the principle of starting simple, scaling gradually, you can prevent overfitting and makes it easier to diagnose performance issues. The number of neurons per layer here, typically is set between the size of input and output layer. Too few neurons may lead to underfitting, but too many may also lead to overfitting. Yeah. And avoid over-engineering. Resist the temptation to make the network too deep or too complex right from the start. Simple architectures often perform surprisingly well. And to choose the appropriate activation function, yeah, here's a guideline for you. So for the hidden layer, you should use ReLU with its variants, right, to prevent vanishing gradients and improve conversion. Squish can also be considered for better performance in some deep networks. For the output layer, it's recommended to use sigmoid with binary classification, softmax with multi-class classification, and for regressions, it's recommended to use linear activation function. So in designing ANN, you also have other problems to pay attention to, like the whether or not, okay, you can apply several regularization methods in order to prevent the model suffering from overfitting, whether or not should we use batch normalization so that the model can converge rapidly, and the learning rate, okay, which values suitable so that you can control the learning process in possible time durations, and also can converse as quick as possible, etc. And so these problems I will introduce more later, yeah, to help you first understand the problems and the techniques to control, and in which situation, yeah, which kind of solution will be the best, okay, in order to solve it. Okay, so for designing, I will put you to try with the first example. So suppose you are working with the marketing department uh, in a company, So they want to predict the customer response by basing on some information or some features of the customer, like advertising spend and the customer data, like the age and the revenue of the customers. Yeah. So you want to predict whether or not the customer will respond or not. The response here might be they open the email, they accept the offers, or they buy the products, etc. It depends, right, on the case you are dealing with. Okay, so let's try yourself. Okay, you can pause the video for 5 minutes to think of the answer. Here, I show you the sample answers. Right? So firstly, you should understand the problems first, right? And clarify. So this one is classification problems with it's binary with two possible outcomes of respond or not respond, right? So for designing, okay, so I think this one is structured data. So might be just a simple feed-forward neural network might have, right? So I design here's one possible solutions, right? With the three layers of input, hidden and output layers. Here the input and output layer are mandatory. Hidden layer might be optional. Right? Input layer, because I have three input features. So I design 1, 2, 3 neurons for capturing advertising spend, the age and revenue of the customers. I also add one more, neuron, the bias here to allow the activation function to shift left or right, to introduce more, complexity to handle the problems. So for simplicity, I just simple by designing only one hidden layer with three neurons, right? Three neurons. And the output layer here, so follow the principle I designed two neurons for capturing two outcomes, right? Respond or no respond. Yeah. And I use a ReLU for activation function of hidden layer. And for the output layer, because it's a binary classification, so I will choose sigmoid, right, as recommended. Here's one possible solution. And how about you? What is your solution? Okay, now let's move on the second example, that is to image classification. So the problem here is you are given an image that capturing something, right? And I want you to build a classifier in order to distinguish whether the input image is an apple, a banana, or other type. Okay, try it yourself first. You can pause the video for 5 minutes to think of the answer before looking at the sample answer I show in the next slide. Okay, so again, similar to the first example, in this case, it's also classification problem. Okay, so I can design a simple FFNN, feed-forward neural network, right? And for each image, okay, later I will introduce to you that image here is can be, vectorized, right, through the pixel, so that flatten into the vector of the number here. And for each pixel, right, I design one corresponding neuron in the input layer, right, in order to capture the number of the pixel, right? Also add the bias, okay, for the for introduce the flexibility of the model. The hidden layers here. Okay, so I may choose to design two hidden layer with several neuron, right, in each layer. Next, the last one, yeah, we have three outcomes. So I design three neurons in the output layer because this one is multi-class, more than two, right? So it's recommended to use a submask, right, for activation function of the output layer. And for the hidden layer, I also still use ReLU, right? ReLU. So this one possible solution that might work for image classification task. Okay, show me your own.